Welcome to this lab. We are going to see how to develop an app with the Vertex AI Gemini API. So first we're going to activate the Cloud Shell. Maximize it to the next window. So just to list out the active account name and also list out the project ID. So we're going to go to the task 1, how to configure your environment and project. So we're going to enter this to set up the project ID, region, and that's it. So you have already set up your project ID and the region. In order to use various Google services in this lab, you must enable a few of the API. Yep, it's already enabled, and now we can check the first one progress. Yes, it's successful. Now in task 2, we're going to set up the application environment. So first we will create a directory called Gemini app and change to the directory. So we are now inside the Gemini app folder. We will set up the Python virtual environment. So this is how you do it. To create the Python virtual environment from within the Gemini app folder, run this command. So the WhenV module creates a lightweight virtual environment with its own independent set of Python package. So meaning you can have different Python version inside your own virtual environment beside the base environment. So I have already activated the Python virtual environment. Now we're going to install. You can see that we are inside the virtual environment now. So we need to install application dependency. A Python requirement file is a simple text file that lists the dependency required by a project. So to start, there are 3 modules we need in our requirements file. Our app is written using Streamlit, an open source Python library that is used to create web apps for machine learning and data science. The app uses the Vertex AI SDK for Python library to interact with the Gemini API and model. Cloud logging is used to log information from our application. Let's do this now. So these are the application dependency we would like to install, and this file is called requirement text. Now we're going to install this dependency. So PIB is the package installer for Python. So you need to wait until all the packages are installed before you can continue to the next task. Yep, it is finished. Now we will move on to the task 3. So we're going to create an app py entry point code. So these are the coding inside, right, written using Python. If you want to view the contents, you can also use this command cat to view what is written inside. So the app uses Streamlit to create a number of tabs in the UI. In this initial version of the app, we built the first tab, Story, that contains functionality to generate a story, and then incrementally built the other tabs in subsequent tasks in the lab. The app first initialized the Vertex AI SDK, passing the value of the project ID and region environment variable. It then loads the Gemini 2.0 Flash model using the generative model class that represents a Gemini model. This class includes methods to help generate contents from the text, images, and video. The app creates 4 tabs in the UI: name, story, marketing campaign, image playground, and video playground. The codes then invoke the render tab function to create a UI for the story tab in the app's UI. So to write code that render the story tab, run the following command. Okay, I clear this first. Okay, so we have done with the story tab. It's pretty long coding here. So end of file. So now we are going to view the contents again using the cat. This is the contents. So the render story tab. The render story tab function generates the UI control in the tab by invoking function to render the text input fields and other options. The generate prompt function generates the text prompt that is applied to the Gemini AI. The prompt string is created by concatenating user enter value in the tab UI for the character of the story and options such as story length, short or long, creativity level low or high, and the story premise. The function also returns a temperature value based on the selected creativity level of the story. This value is applied as the temperature configuration parameter to the model, which controls the randomness of the model prediction. So the maximum output token configuration parameter specify the maximum number of output tokens to generate the message. This one. So to generate the model response, a button is created in the tab UI where the button is clicked. The get Gemini text response function is involved, which we will code in the next step in the lab. Okay, let's move on to the, we're going to create another code. So this is called response util. You can view the content using the cat as well. The get Gemini text response function uses the generative model and some of the other classes from the Vertex AI preview generative models package in the Vertex AI SDK for Python. From the generate content method of the class, a response is generated using the text prompt that is passed to the method. A safety setting object is also passed to this method to control the model response by blocking unsafe content. The sample code in this lab uses safety setting values that instruct the model to always return content regardless of the probability of the content being unsafe. You can access the content generated and then adjust this setting if your application requires more restrictive configuration. So now the task for run and test the app locally. Okay, how do you test this app? So you can do the string run app py, and this will generate a URL to access the app. You can click on the link. So this is created. This is how it looks like. I'm gonna put it back. So you can leave it as the default setting, and we can click on generate my story and see how it goes. You can wait for the response to be generated, and then so we are in the story response tab. So this is very interesting because after you've given all the character name and the type of character and the personality and also where does the character live, straight away there's a story created for you, and they have even created multiple chapters. Now you want to see the prompt, what prompt that is using. So this is the prompt. Write a short story based on the following premise. Our progress. Yep, it's done. So we move on to task 5, generate a marketing campaign. So we go back to the Cloud Shell, and now we create another new Cloud Shell tab. So this time we're going to write and render the marketing campaign tag in the app UI. I think that is done. It's pretty long coding as well. We can read it back by using the cat as well. Now we can test the app marketing campaign tag. So after I refresh the page, so in the marketing campaign tab, leave the default setting and just generate the campaign. Okay, I can see the result is out. So the marketing campaign has the, what is this? You can look at the prompt. So in the prompt, right, you say that you want to generate a marketing campaign for Zhongzhou clothing design for the age group 18-24. The target location is this urban. And to primarily achieve increased brand awareness, allocate total budget of 1,000 to 5,000. With this input, make sure to follow the following guidelines and generate the marketing campaign with proper headlines. So these are the headlines here. And there you go. This is what you get. Now let's check the progress. Yep, it's successful. Now we're going to task 6 now, that is to generate the video playground. Go back to the Cloud Shell here. Let's clear this and we will just write the code to render the video playground tab. So once you finish, you can also read it back by using the cat command. Let me just clear this first. Okay, now we can update the response util as well. Oh, by the way, you can also refresh this. And go to video playground. Oh, that's empty. Oh, because we haven't complete the code. So now let's do this. Update the response util py that contain the function to generate the modal response. And then next one is we will modify UI content for tab 3 to the app run the following command. Now we can test by reload. Let's look at the video playground tab. So you can click on the video description, video playground and video description. The tab will display a video of a place. You can play the video. Wait until the video finish playing before continuing to the next step. Okay, the video is finished. Now let's generate the video description, and you get an error. If you receive this error, service agents are needed to read the cloud storage file provided. So please try again a few minutes. Wait for a few minutes, then click the video description again. Or you can also take a look at the prompt, see what they you can't because there's an error. Okay, the response is created, and then you can look at the prompt as well. What am I looking at? Where should I go to see it? What are the top 5 places in the world that look like this? So these are the top 5 places. Now let's check the progress. Yep, it's done. Now the task 7 is we're going to generate a video text. So go back to the Cloud Shell. I run this. So the code built the UI of the video text tab. A video is used along with the text to prompt the model to generate text and answer questions about the scene in the video. Now you can go back to this and refresh, reload the page, and go to the video playground and click on the video text. So the tab display a video that will be used to prompt the model. Now let's play the video. Yep, it's done. Let's click on generate the video text. Okay, so here is the table with the answer to your question is based on the provided video. Anyway, you can look at the prompt, answer the following question using the video only. What is in the video? What objects are in the video? What is the action in the video? Provide 5 best text for the video. Write the answer in the table format with the question and answer in the column. Well, it takes some time for the text to come out. So what's in the video? A man in a hat taking a picture in the room. Second, what objects are in the video? Table, chair, camera, hat. Wow, this is so detailed. I will say I'm very impressed with this AI response. I can check this progress. Yep, it's successful. Now we move on to the task 8, which is to generate video highlights. So I go back to this to implement the code for the video highlights tab in the video background. So the code above built the UI of the video highlights tab. A video is used along with the text to prompt the model to generate response from below. Now let's reload the website. And I go to the video playground and click on video highlights.
島田彩香です。東京でフォトグラファーをしています。東京にはいろんな顔があって、夜の東京は昼の東京と全く違うと思います。新しいピクセルには動画ブーストって機能があるんですけど、暗いところだと夜景モードが作動して画質がさらに上がるんです。三茶は上京して初めて住んだ思い出の場所なんです。いい感じです。お、綺麗。次は渋谷に来ました。みんな。
Okay, let's click on the generate video highlights. So the video highlights 3 things. What is the profession of the girl in this video? And which feature of the phone are highlighted here, and summarize video in 1 paragraph. So this is the prompt. So I'm going to check my progress. Yep, it's done. Now go to task 9 to generate the video location. Go back to my Cloud Shell, clear this and run. So to test, go back to reload. Again, video playground and go to video geolocation. Let's run this. So they will display the video. So this video will be used in the prompt for the model to the prompt to model, click to generate the response. So it's done. Let's click on generate. So here are the answer to your question. What is the video about? And how do you know which it is? What street is this? And what is the nearest intersection? Okay, I can check my progress. It's also done. Now go to the task 10, generate the image playground. I will go back to Cloud Shell, clear this, put on this code. Just to say that I want to view back the code, you can use the cat. So the render image playground tab function build the UI that enable the app user to interact with Gemini model. It create a set of tab furniture recommendation, open instruction, ER diagram, max reasoning in the UI. You can write the code for remaining tabs in subsequent tasks in this lab. So in the furniture recommendation, a living room scene is used to perform visual understanding. Along with a set of additional image of chair, the code uses the model to get a recommendation of chair that complements the living room scene. Okay, so you can modify the main app entry point to add UI content for tab 4, image playground. Run the following command. Okay, it's done. Now we go to the same website and reload. And we will go to the image playground, furniture recommendation, and then we will click on generate recommendation. Okay, so the response is out, and then you can see they have different reason for different chairs. Not suitable, suitable, not suitable, suitable, which is very interesting. And this is the prompt. Let's check my progress. Yep, it's done. So in the task 11, analyze the image layout. Back to here, clear this, and I'm gonna run this. So this will equip the ability to extract information from visual elements on the screens. Gemini can analyze screenshot, icons, and layout to provide the holistic understanding of the typical scene. In this task, you provide an image of a kitchen oven control panel to the model, and then prompt the model to generate instruction for the specific function. Okay, so back to this and reload. In the image playground, go to oven instruction. You can test the app and click on generate instruction. The result is out, and you can see the instructions given. Let me check my progress. Yep, it's completed. Now we move on to task 12, analyze the ER diagram. Gemini multimodal capability enable it comprehend diagrams and take actionable steps such as document code generation. In this task, you will use Gemini 2 Flash model to analyze the entity relationship diagram and generate documents on the entities and relationship found in the diagram. So let's go back to Cloud Shell, and I'm going to write this code. The code above will build the UI of the ER tabs, ER diagrams tab. An image of an ER diagram is used along with the text to prompt the model to generate documentation along the entities and relationship found in the diagram. So let's go back to here and reload the website. Image playground, ER diagram. Yep, you can click on generate documentation. So this is the documentation of the ER diagram. They even display the relationship between each entity. Now I will check my progress. Yep, it's done. Now the task 13, max reasoning. So Gemini 2 Flash can also recognize max formula and equation and extract the specific information from them. This capability is particularly useful for generating explanation for a max problem. Back to the Cloud Shell. Now we're going to implement another new code, which is this one. Now we go back here, reload, image playground, max reasoning. Let's click on generate the answer. Look at the information given here. Well, they're trying to explain the formula to you. Hope you can understand. Now I check my progress. It's done. Go to the task 14, deploy the app to Cloud Run. We are ready to deploy the app. Go back to the Cloud Shell and the Gemini app. So let's verify again the project setting. So if the environment are not set, then you can run the command here to set this again. Then now we set the environment for the service and artifact repository. These are the one. And then next we're going to create a Docker repository. And set up the authentication to the still running, sorry. Have to wait. And set up the authentication to the repository. Okay, it's done. Now we can build the container image. We will use Docker file to build the container image for our application. A Docker file is a text document that contains all the commands that a user could call on the command line to assemble a container image. It is used with Docker, a container platform that builds and runs the container image. To create the Docker file, you can use this command. Yeah, it's all done. So next we're going to build the container image. So the G-Cloud build submit command, submit a build using Cloud Build. When used the tag flag, Cloud Build uses a Docker file to build a container image from the application file in your source directory. Cloud Builds is a service that executes builds based on your specification on Google Cloud and produce artifacts such as Docker container or Java archive. Okay, it's finished. Now we're going to deploy and test the app in the Cloud Run. So run this command. Okay, after the service is deployed, a URL to the service is generated in the output. This is the one, and you can click on it. It will open a separate browser tab or window, and you will see the same thing that you see before. Yep, there you go. Let's check my progress. Yep, it's all completed. Thanks for watching. You can end the lab.